Good morning, Tahmina Khan is here in TKMaths is Fun. In today's video, we will see a concept of vectors, which is distance from a point to a line. This concept is asked in multiple ways. I have made 2-3 videos on it. I will put the link on my blog address. You will see it is here, and I will put it in the description as well. This is a topic from year 13 A level P3. This question I have taken from November 22, variant 3.1. So let's see the question, and you will see why it is different and little challenging as well. So first of all, let's start writing the values given in the description to make our working easy, so that we don't need to read the question and again. Okay, so first of all, the thing is OA equals to OB equals to 4 unit. So it means this is equals to 4J, this is equals to 4I, and OD is 3 unit. It means this is equals to 3K. Beside that, it is given DC is 1 unit and it is parallel to OB, right? So this and this is parallel. It means it is 1J, which means just one, a J. And another thing is AB is, M is the midpoint of AB. AOB is 90 degree. And last important thing, CN equals to 2NB. It means this has ratio, let me write with other color. It means this has ratio 2 and this has ratio 1. Now we have put down everything, and it is always the best practice to write down all the values and ratios on the diagram, so that you don't have to read the question again and again. So first of all, let's find out the vector MD. The best way is to find out the root. What is the other way to go from M to D? So if we look at the diagram, we have to select the ways which have vectors, known vectors. So for M to D, I will go M to B first. Then from B, I will go B to O, okay. Then from O, I will go to D. Okay, so now I will write down vector along this. For BO, I know, if you see BO is in the reverse direction, it is equals to minus 4J. And OD, which is this, is equals to 3K, right? 3K. What is MB? MB I don't know, but I can easily find out AB. The only reason is I know OA and OB. M is the midpoint, so basically MB is half of AB. Agreed? So let me find out AB quickly here. This is a displacement vector. I will change it into position vector. And I have explained earlier, it is equals to second minus first. Now OB, from the diagram you can see from this side, it is equals to 4J and OA is 4I. Right. So I will just write these values here. It will be half 4J minus 4I plus minus 4J plus 3K. So if you simplify it, you will get minus 2I minus 2J plus 3K. If this is too direct for you, so basically I'm opening the bracket, expanding, and I believe that at this stage in P3, you can do this easily. That's why I skip this step. But anyway, so from here you are getting this. Okay. So this is your MD vector. And now let's find out ON vector. This is the second part of the question. Okay, this one. So it is ON. Let's see what root can help us. Root means the path I'm talking about. So now I have to find out, let me erase these extra lines which I drew earlier. Okay, so now to find out ON, which is this, I will take the root of OD, DC and CN. Okay, this is the root I'm writing it. So I'm writing OD, let me write here first, OD plus DC plus CN. And now I will substitute these vectors. So what is OD? OD is equals to 3K, DC is equals to J, and Cn is equals to 2NB, which was given to us in the question. Okay. So I will write OD is 3K, this was J, and this is 2NB. Now again NB I have to find out. it is a displacement vector, I will change it into position vector, OB minus ON. Now OB is given to you in the question. What was that? If you see, OB is equals to 4J, right? Sorry. So I will write here 4J. ON I don't know, I will keep it as it is. So let's plug in the values here. So it will be 3K plus J plus 2 times 4J minus ON. Okay, vectors, please use this symbol. If I forget, you don't forget. Okay, so it is 3K plus J plus 8J minus 2ON. Now I have ON on the left hand side and right hand side. I'll bring it to this side. It will become 3ON. So here I have 3K plus J plus 8J. Now 8J, 1J will be equals to 9J. Yes or no? So it will be equals to 9J and this is 3K. And this 3 which is here will go as a divider here, and this will give me what? 3J plus K. So this is my vector ON. Now I have done part 1. Let's see what is part 2. Calculate the angle between MD and ON. Now MD was here and ON is here. So we just have to apply a scalar what it is called? A scalar product formula, right? Or dot product formula. Scalar product or dot product. So which is MD dot ON is equals to modulus of MD, modulus of ON, modulus and cos theta. So let's write down the vector here. So vector MD we have calculated, which is here -2, -2 and 3. Okay, so -2, -2 and 3. And vector ON is here, dot, I is not here, so 0, because you see there is no I here. 0, 3 and 1, right? So now modulus, you know what to do. I will square each one of them. -2 is square is 4, this -2 is 4 and this 3 is 9. Now I will take modulus of ON. 0 square is 0, 3 square is 9 and 1 square is 1. And I'm sure you know how to handle dot product. You multiply this by this, this by this and this by this. So -2 times 0 is 0, plus -2 times 3 is -6, plus 3 times 1 is 3. And what this will become? Just write down as it is 17 and 10 and cos theta. So this one become -3 over root 170 cos theta. So now when you will calculate, you know you will get theta equals to 103.3. Now remember one thing, when you will use calculator, if you don't use this negative sign, if, you will get answer 76.6. You can try it in the calculator and then you minus it from 180. Do you know why? If you remember this trigonometry, we write ASTC. In the first quadrant, cos is positive, but in the second quadrant, cos is negative. So when we have a negative sign here, this is giving us very clear hint that the answer is lying in the second quadrant. So it will be between 90 and 180. Anyway, calculator will give you straight away this answer. You don't need to worry about it. So you have calculated this value. Now let's see the last part. Show that the length of the perpendicular from M to ON is this, 22 over 5 root. Now this is a tricky or challenging part for most of the students. Now let's see in the diagram where is ON and where is M. Okay, so ON is here and M is here. So you have to draw a line which is perpendicular to it, right? Not draw, but rather you have to find out this distance. So let's see I'm drawing roughly here a diagram just to give you an idea. So this is your ON and M is a point here, and it is perpendicular to it. So you have to find out this distance. Let me call it P. Okay, so I have to find out basically MP. This is the whole thing. Now MP is actually equals to what? MP is equals to OP minus OM. Okay, now OM you have already calculated here, if I'm not wrong. No, you have not calculated. You will have to calculate OM. So let's see from the diagram here. This is OM, right? So I can take what root? I can take OA plus AM to calculate OM. So let's calculate OM first, then I will come to OP also. So OM is equals to OA plus AM, and OA is equals to 4I, you can see here, and sorry, it is erased. This is equals to 4I, okay, and AM is half of AB, okay. So 4I, and this is half of AB, and we have just calculated in the above part half of AB, if you remember. So we'll use from there the values here. We use it here, half AB, which is equals to 2J minus 2I. So I'm going to use this value. So it will be 2J minus 2I. Right, I'm just picking it up from the above value which we have calculated. So this will be equals to 2I plus 2J. So I got my OM, which I can write here easily. The problem is I have to find out OP. Now here you need to understand one thing. P is a point on ON. Now you have the equation of ON, which is, direction of ON, which is here, 3J plus K. Now focus on this point. 3J plus K is the direction of ON. Let me write here. ON is equals to 3J plus K, right? If I want to find out the vector equation of ON, just giving you an idea, and vector equation is always what? A plus lambda B, right? A is a fixed point. On ON, if you see, the fixed point is origin, which is like 0, 0, 0. So I can ignore writing it. So what will I get here? ON is giving me direction also. So this vector itself is giving me direction of the line ON. So it is 0, 3 and 1. So my ON will be, it is erased, sorry. So my line will be lambda 0, 3, 1. This will give me this lambda. This lambda, if you changes, will give you different points on this line. On which line? On this line, right? Because when you write a general equation for ON, this change in lambda will change the position here. So basically I can say that this equation is my OP equation, right? This is the reason and understanding behind it. So I can write here that OP is lambda times 0 is 0, lambda times 3 is 3 lambda, and lambda times 1 is lambda. And OM was here 2, 2, 0. I'm repeating this concept if you have little confusion in it. When we have to find out OP, right? P is a point on ON. And if you have the line ON, which is here, right? Why we have find line OR here, ON here. This value of lambda, as you changes the value, will give you any point on line ON. Okay? So that's why I can say that this is my equation of OP as well for any particular value of lambda which I will find out. Okay, so now I will simplify it. 0 minus 2 is minus 2, 3 lambda minus 2, lambda minus 0. So I got MP. Still, if you have confusion, you can write the comment in the comment box, and then I will explain it to you again. Now I have this MP. Okay, we have to find out value of lambda. So what you can do here, this MP direction and the direction of the line are perpendicular to each other. So you will use the concept of dot product equals to 0. When two vectors are perpendicular to each other, we put the dot product equals to 0. So I am taking MP with the direction of ON. What is the direction of ON? This one, 0, 3, 1, right? Which was from here. So I will write 0, 3, 1 equals to 0. It means this direction and this direction are perpendicular to each other. And MP is what? Minus 2, 3 lambda minus 2, lambda dot 0, 3, 1. So let's solve this equation to get the value of lambda. 2 times 0 is 0. 3 times this thing will be what? 3 lambda minus 2, and lambda times 1 is lambda. So let's quickly solve it. 3 3 is 9, 6 plus lambda. So it will be 10 lambda equals to 6. Lambda equals to 6 upon 10, which is 3 upon 5. So I got the value of lambda 3 upon 5. But I have to find what? A distance, MP. So this is my vector MP. In this vector, I will plug in the value of lambda and take its modulus. So let me make a box here just to differentiate it. So my MP vector is minus 2, 3 times 3 upon 5. I'm just plugging in the value of lambda here. Minus 2, and then lambda is 3 upon 5. Okay, so it will be minus 2, 3 3s are 9. It will be minus 1 upon 5 and 3 upon 5. Now I will take modulus of this. So modulus of MP, which will give me, you can use calculator straight away. Yes, so it will become 4 plus 1 upon 25 plus 9 upon 25, which is equals to, calculate it, 22 upon 5. So you have proven that the length is 22 upon 5. So this is how you will solve this question. I hope you understood this. Thank you very much for watching this video. Please press like and subscribe button and share it with your friend. Thanks a lot. Take care. Allah Hafiz.